with that, I will move on to the next session. The next session we have two people presenting. We have Manish Arya, Chief Technology Officer and co-founder of Tawant. Manish was previously with Sarvesh at Amazon and at Journey working on the e-commerce platform. And before that at the IBM Research Center. And he has a bachelor's and a master's degree in computer science from UC Berkeley. Let's welcome Manish on the stage, please. And with him, we have Aseem Mito. Aseem has over 30 years of total business experience and has held numerous leadership positions in the financial services and technology industries. He started his career as a mechanical engineer in operations research and optimization, programming in Fortran. His interest in optimization served him well, and he eventually became the CEO of ACC Capital Holdings, the parent company of Argent and Ameriquest Mortgage Company. ACC was a top 5 mortgage lender with 20,000 employees and more than 125 billion a year in originations. The company was acquired by Citigroup in 2006. At ACC, he led the development of quantitative predictive modeling applications in all aspects of mortgage lending and servicing. He was doing machine learning even before it became fashionable. He is currently a consultant to financial services companies and private equity companies on M&A transactions. Aseem is a UC Davis certified winemaker and a partner in a vineyard and a winery in Mendocino, California, and a level 3 sommelier. You will experience the results of that later in the evening today. Aseem is the co-founder of Tawant and has been on Tawant's board since inception. Welcome Manish and Aseem. Thank you.
I don't know about this Fortran stuff. I think it may be coming back because I recently heard that turntables and vinyl is back, and I think that's pretty cool. It's one of the top selling items on Amazon. So check it out. But apparently that's back, so I think we may be programming Fortran soon. I don't think this guy would agree, but it's one language I'm very comfortable in even today. So as the second mechanical engineer here today, I'm just honored to be co-speaker with him. This guy's really smart. I'm here to tell jokes and show you videos.
Now we got a lot smarter people in the room and the team here. So hey, good morning everyone, and thank you for coming. It's great to see this turnout. Guha made some great points about data being the key. That we need to collect more, we need to be able to understand the semantics of it. We want to share it with others and not just sometimes keep it to ourselves, and bring in new information, new signals, so we can derive additional value. We want to, in this session, get into the mortgage industry. Okay, mortgage lending, what can we do with machine learning? And I was tempted for a moment to go change everything to empirical modeling, as Guha suggested, but so just bear with me. We'll use ML everywhere here. That's kind of what flows off the tongue right now. Elon Musk, when he's not making cool products, he's out. Do we have the mic? Yeah, you keep that. All right, is this working now? Okay, great. So when he's not building cool products, he's got opinions on a lot of things like AI. And as you can see, if you're a competitor, what he says, we kind of agree. If your competitors are doing this and you're not, they can crush you. So our goal here is not to scare. Our goal here is to inspire you because there's a lot of opportunity. So let's go on. We'll start with an introduction. And just to supplement all the things that Guha has said, we do see ML everywhere. Here's our list. You've seen this in housing value prediction models, self-driving vehicles, robo-advising for investments, fraud detection, disease diagnosis, voice recognition, lots of areas, right? And you knew all these companies. But what about mortgage lending? And we'll get to that later on after this overview. So here's one example, and you can cue the video from Waymo. I thought it would be interesting for you to see we know about self-driving vehicles. Some of you might have one. It's like a Tesla that have some level of autonomy or seen the Google ones driving around. But what does the car see? Okay, so this is a video on. So a lot of the algorithms that are used here are to do things like identify obstacles, street signs, looking at cameras and LiDAR sensors and so on. Well, we get the AV issues going. All right, great.
The vehicle to recognize and navigate through construction zones. Our sensors spot the orange signs and cones early to alert the car of the lane blockage ahead, and we can change lanes safely. You'll also notice the vehicle typically moves to keep a safe distance away from large obstacles, like this truck stopped on the side of the road. Now we're approaching a railroad crossing, which requires special care. Notice the red fence and railroad sign that appears to the computer as we approach the intersection. This means that we'll wait until the tracks are clear of other vehicles before proceeding. Our cars treat cyclists as a special category of moving object. Watch in this example, when the cyclist holds up his arm, our software detects the hand signal and predicts his movement into our lane. The car knows to continue yielding to the cyclist passing by, even when he changes his mind, multiple times. We still have more work to do, but it's fun to see how many situations we can now handle smoothly and naturally.
That last part with the hand signals was surprising to me too. Like, that's pretty amazing. So as you can see, the ML models here are being used to do things like detect, when you have all the data from the depth sensors and from the cameras, is to identify where the obstacles are, what the obstacles are. And that's just one interesting application that has a lot of sophistication behind it. So let's get a little bit into terminology, since we hear this a lot in the industry and in everyday conversations now. What is ML? What isn't ML? Well, Arthur Samuel was one of the pioneers in the field of AI, and back in '59, quite a while ago, he coined this term machine learning. And I think, we like, Asim dug this up, and I agree with him, this is a great definition. It's the field of study that gives computers the ability to learn without being explicitly programmed. We'll talk about that more in a second. So ML models can, for example, learn from examples to cluster, right? Group similar customers together based on some behavior, or to forecast, what are my expected losses on a mortgage insurance policy? We've got some MI companies out here. Or classifies things, like in the Waymo video, right? What's a stop sign, what's a pedestrian? Recommend, what's the best loan product that makes sense for my borrowers based on everything that we know. So let's cue one more quick video here. How many of you watch Silicon Valley? All right, a few of you. So let me give you the background. So it's an HBO series, and I apologize, there's some explicit language in here, but I hope you guys are all cool with that. And it's relevant to the topic.
It's HBO.
Okay. Yeah, and don't just pause it for a second. Yeah, I need to give the background. So this is about Silicon Valley culture. We're in Silicon Valley right now. Startups, entrepreneurs. So here's a scene where this gentleman on the screen has been tasked with building an app for seafood. Now there's some confusion that wasn't part of the setup, which is he originally wanted to have a seafood recipe app, which no venture capitalist wants to fund. And in the meeting, the VCs misunderstood that to mean an app which would see food and identify it. Okay, and so they went with that, let the VCs misunderstand, and now they have to deliver on the promise. Okay, so that's what this is about. The first demo, right?
Please God, what will you say if I told you there is an app on the market?
Well, that's that part. Just demo it.
That's right. Your puzzle.
Holy shit! Oh, motherfuck! Julian, my beautiful little Asiatic friend, I'm going to buy you the palapa of your life. We will have 12 posts, braided palm leaves, we'll never feel exposed again.
I'm gonna be rich. How much you kill for?
2 pizzas.
Let's do pizza.
Yeah.
Hey, Seth.
That's it? It only does hot dogs?
No, and a not hot dog.
All right. The rest of the talk isn't that funny or interesting, so, but we'll continue. All right. So, question for you, right? So if you see these examples, can you read at the back, or the 2 lines on the bottom? So which of these demonstrates machine learning? You know, let's talk about a fraud problem. We have that in our industry. Interviewing a fraud investigator and, you know, building a system with the rules that you learned from that interview. Okay, that's choice A. Choice B is studying past data where you have known instances of fraud and letting the algorithm look at all the data you have. And I guess I kind of gave away my question, but looking at the historical transactions and looking for fraud. Looking for patterns to predict future fraud. So obviously, you can go. Obviously, it's the second one that's machine learning. The first one is what we often have when we say we built a rules system or an expert system. And the idea is, I think we can do better than that. So how is that explicit programming point? How is learning from examples, learning from the data, how is that better than explicit programming? Well, we have a human tendency to keep doing things the way we've done them before, okay? That intuition has served us well, but when there's more information and things change, it's important to consider other possibilities. And then algorithms can kind of do that, being blind to what we've done before, all right? You can learn from massive data sets. You can adapt continuously. It's not practical to have analysts who are going to go crunch numbers every day when new information flows in, but we can do that. Every time you see another event with a loan that you originated, you can feed that into the training system and let the machine learning model retrain on new information and make that automated. It eases development, at least after getting over some of those initial hurdles Guha touched on. We need to make the development of this easier. And specifically, like in the Waymo example, there's a lot of tasks where an expert can't tell a computer what to do, right? Like, how do you describe what a hot dog is? How do you describe what a pedestrian is? And this is one of the areas where, especially these deep neural networks, we'll get to that, have shined. Another take on terminology. So I don't like using the word AI either, but you know, we hear it a lot. You'll hear less of that, I think, today from us.
We do hear it a lot in the movies, so, you know,
Right.
there's 2 kinds of, and we've got a few video clips here that, you know, we're gonna make sure we keep bringing back AI, but he's gonna keep bringing it back to machine learning, which is really what we're here for. But given it's part of this bigger field of AI, I think it's good. And as Surveyor said, that, you know, what inspires people at large often is Hollywood. You know, just, you know, there are a lot of, and then there have been a lot of scientists and philosophers and futurists that have predicted a lot of these things. I don't know how many of you were paying attention to that video playing when you guys walked in. Those
Nigel
robots,
Stanford,
yeah,
yeah.
Nigel Stanford and those robots. There's a video then that also playing ping pong. Pretty amazing. I mean, you can think about the acuity and coordination that was involved in kind of putting something together. There's a lot of advancement in that. And were you going to explain like the 2 types of AI just to get that out of the way?
Sure. You can keep that if you need to jump in.
Yeah.
So we'll get to the narrow and general in a second, but AI, the way a lot of people are using it today when they see systems at work is, loosely speaking, any system that's attempting to model human thought, perception, interaction. So when we see game-playing machines, natural language processing, automated speech recognition, robotics, expert systems, loosely speaking, these are all AI. I actually don't even know how to define this better. But there's a subset of AI that is concerned with automated learning, machine learning, right? And from data, from examples, from rewards, and that's what ML refers to. So it's within the general topic of AI. And within that, you have a specialized technique called artificial neural networks, which are modeled after the human brain. And when you make them, when they have lots of layers, they become deep neural networks. So that's where we talk about deep learning. And this is where you've seen innovations in self-driving vehicles or in machines that beat champion game players and so on.
We actually have a session this afternoon, so I just want to, that we actually developed a few models from data in this industry, and we're going to actually have a hands-on exercise where we will compete against the machines who have been taught some pretty cool things. Now those machines won't play music, but they are very good at telling good loans from bad loans.
All right, and so let's talk about some other terminology that we hear, all right? So you might hear sometimes descriptive, predictive, and prescriptive analytics. Some people think of these as marketing terms, but essentially it's like, well, descriptive is what the old-fashioned BI and reporting. What happened, and can you report on it? So what were my sales last year by product line? Predictive is forecasting. This is where we start to use machine learning. So what would my sales be next year, okay, under some set of assumptions, and forecast them for me. And prescriptive is, well, what should I do to influence these sales? What marketing offers should I run? How should I touch my customers? So what's the next best action? And these two, as I said, are areas where ML comes in. And then on the ML side, you hear other terms: supervised machine learning, unsupervised machine learning, reinforcement learning. So supervised is learning from labeled data, data that's been tagged. So if we're going to study credit risk in a mortgage, right, or a mortgage insurance policy, if we have data of past loans and we know how the borrowers behaved, did they default, did they pay back, did they default and then become current again, whatever. All of that is the labels and the data, and that's what algorithms can learn from when it's supervised, right? Unsupervised is when you don't have those labels in the data and you're looking for patterns. Sometimes this is like anomalies, right? Fraud detection sometimes works that way. Tell me when something is outside the norm, right? Or just group similar customers together. And reinforcement learning, I think, has gotten a lot more interest and application recently, especially in game playing. And this is where you use rewards. So when a lot of the machines, and this is AlphaGo from Alphabet's DeepMind subsidiary that beat a world champion. Reinforcement learning is the idea that explore what all the moves are you can make. Okay, just try. Okay, and then see what happens. Did you ultimately win or not? That's a reward. Okay, so no one's really telling it what strategy to use. It's just trying all kinds of things by playing numerous games over and over again. They evolve in different ways, and then it sees what the ultimate outcome was, and that's a reward. It turns out AlphaGo uses two kinds of techniques, at least, and more I'm sure. It also uses supervised learning because it studied old games. So they also set it up to study, I think, millions of board positions, and did they ultimately lead to a win or a loss? So individually, were they advantageous? So that also guided the system along the way, so it didn't have to start totally from scratch. So we're gonna, as Asim said, we're gonna have a session later on where we get into more depth of how to build a machine learning model. But just to give a really high-level idea for those of you, I know many of you understand this, but what does it mean for an algorithm to learn from the data, right? So this is an example from Microsoft's Azure machine learning webpage. So imagine that you're solving this important problem of predicting who's going to attend the Burning Man Festival. That's the data set here. So let's look at the left. Ignore the green lines first. Okay, so the left axis is income, and the horizontal axis on the bottom is age. So they've plotted all of the points here. So people who attended Burning Man are in that gold or yellow circle as marks. And the others, the triangle, the blue triangles represent people who did not. Okay? So what this representation on the right is a decision tree that can be generated not by a person, but automatically by studying the data. And there are algorithms that will explore the data and try to organize it, okay, so that every time you go down the tree and ask a question, there's more homogeneity in the data set. So is the income less than 61K? The algorithm figured that it should draw this horizontal line here. If the income is less than 61K, well, you see a lot of blue triangles, all right? So those are people, so a new person, thank you. Almost there. Still searching. Okay, so I'll talk through it. If you remember the bottom half of the diagram, that represents the people with lower incomes, and it looks like they don't attend Burning Man, so when you make a new prediction, that might be the first question you ask. Above that line were people that had different age ranges, okay, and it turned out that there's a certain middle range that that the attendees tend to fall into, and the decision tree building algorithm had figured that out. So this is a trivial example because it's got just two variables, okay? Because you could stare at that scatter plot and say, just draw a box here, those are the interesting sets. But the point is, in the real world, you've got huge amounts of data, you've got hundreds of variables, sometimes thousands of variables, okay? And how much exploration are you gonna be able to do on your own to try to figure out what is a good predictor? Okay, so the point is that you can accelerate the discovery of good prediction models by using these automated techniques, and it very quickly gets away from a problem that you can grasp in your head. You know, these artificial examples are just two-dimensional.
So actually, in the lending business, you saw that scatter plot, right, where the machine has the ability to start creating these thresholds and segments and kind of work with the pattern of the data, as compared to the old time regression problems where we're used to seeing, you've got one variable, maybe you had two, maybe you had three, and you tried to predict some linear relationships, and you could say, oh, our regression analysis tool will say, hey, number of bedrooms is correlated to the value of the house, okay? But these models, with more and more attributes, they can get very sophisticated and start creating all these thresholds and find these kinds of relationships, or even these binary outcome relationships like hot dog, not hot dog. But as funny as that one was, it's actually a very interesting problem in our industry, which is, at the end of the day, most of the time we're trying to predict, which are the good ones, which are the bad ones. It's really, if you want to simplify it.
Are the good borrowers hot dogs or not hot dogs?
I have to think about it. I prefer pizza, but, or, it's kielbasa maybe, I don't know. So, there you go.
All right, so I don't think we have time today, but Google's got this library called Tensorflow, which is for doing deep learning, and there's an interesting interactive animation that you can run there. And it's got synthetic data, but you can sort of see a neural network learning in action. And if you have time on your own, you might want to go there. All right, so Guha also touched on this topic of this explosion. AI research has been around for a long time. A lot of these algorithms have been out there for ages. But there's been multiple cycles, I think, of excitement and optimism, and then disappointment or even laughing, right? I think with deep neural networks, the whole idea of neural networks was born a long time ago, but it took a long, it wasn't until recently that they become practical. In the past, there might have even been points in time when people laughed at the whole idea.
Actually, I first used neural network to mimic underwriting decisions in 1996 with a company that had developed a pretty cool, they came out of the defense business. It was called HNC Software. They got merged into somewhere and then they just completely went away. But the technology now is, I mean, conceptually it's the same thing. It's, you know, the algorithms have gotten better, they can do many more levels, and then the computing power is just off the charts.
Yeah, yeah. So interesting thing on the so what's changed, right? On the computing power side, it's not just that Intel and other companies are making faster CPUs. It's that people have discovered that you can use graphics hardware to do computations for deep learning. Okay, so it's so much so that NVIDIA, which is like, this is probably going to become, or already is, a bigger part of their business, where they have now, so we talk about GPUs as graphical processing units. GPUs are general purpose graphical processing units, which are really meant to crunch data, not just for, animated movies and games. Google has in fact got its own special hardware design called a Tensor processing unit, and you can even use that in their cloud offering. So storage, the data that we talked about, that Guha talked about in the morning, and it's not just more rows of data, as he said, but also what other data can you bring in with signals. We'll talk about alternative data in the second part of this presentation. Besides the standard credit, property evaluation, and all that, can you pull in other things like rent and utilities? That can have a lot more power than just more and more examples of loans of the same data. Go back for a second. And open source is another thing. So while some algorithms have improved, the fact that they're open source means that data scientists can now focus on the business problem and less on, oh, how do I code this algorithm up, which was the case a long time ago. The same thing with Hadoop and systems to process massive amounts of data. You need to summarize it, slice it, and dice it in different ways, or even run the algorithms in parallel. That's more feasible today. And these cloud offerings put it all together. You can not only get the Hadoop and storage and all that in the cloud, you can get the GPUs in the cloud now to run these models faster. Guha also touched on the explainability of a model, right? So when we say model, it's what the system has learned from your data, right? And it has representation. So at the top right, you see a neural network with two hidden layers and an input layer and an output layer. These things loosely model neurons in the brain, and the system learns the weights. It learns what math to do along the way, basically. And the bottom is a decision tree, like what we showed you before. So by the way, what you might do here is you might feed in income, you might feed in loan amount, you might feed in other variables if this is a loan application process. And the output could be some level of risk, okay? For example, that's what you're trying to teach it. Or the probability that this is a high-risk case. So it's really important when we apply machine learning. This is one of the challenges, is that do you have a business problem where you need to explain why the machine gave the answer it did? Or is that not so relevant, right? And so you might choose to stay away from neural networks for that reason and go with decision trees, which are easier to explain. And again, there's all these other algorithms like logistic regression, random forests. We don't have to get into them, but they have different properties in terms of how much a human can comprehend what they've done.
And in our industry, again, it's very important that we be able to explain our actions to regulators, to the consumers themselves. Like, hey, why did I get turned down? Or why is my loan priced at this level versus that level? So explainability is relevant. And there are things that each model gives you that actually enhances your ability to explain the decision, because you get the weights. How much did this contribute So,
All right, and besides the explainability, you know, our ability to understand the models, we have other things you have to keep in mind. It's not always easy to get labeled training data, so sometimes that itself becomes a human exercise. Go look at old information and tag it, like fraud, not fraud, or fairness, right? So we have to make sure the data that goes in is representative of all the situations you'll see and not going to lead to racial bias and so on, which, you know, these things are of great concern to our industry here, right? Does anybody remember Tay, Microsoft Tay, that chatbot?
yeah.
Okay, so that Microsoft research had come up with an agent that you can interact with, okay, meant to be human-like, a little fun, and have some personality, and they set it loose on Twitter, where the world could interact with Tay, okay? It very quickly became racist, okay? And it's because, well, it's not exactly a fair scenario, because what's happening is, on social media, you'll see a lot of inflammatory commentary, so it's not really representing the average human speech and interaction for it to learn from. It's seen a lot, and also things get amplified when they're controversial, so there's almost an incentive to be edgy, right? And also, there was just no filtering, right? You know, they just set it loose without, didn't even have like a set of stop words, like don't ever say X, Y, Z, which a lot of software out there has. Permissible use, right? So when we get into the next section, there's going to be a lot of interesting data sets that could be better predictors for lending, but what do you have permission to use, you know, with the existing relationship you have with your customers today? And this next point actually is a very key point. You guys can tell us how much you sense this, but there's a lot of times a lot of resistance to change established business processes. So there can be someone in a company that says, hey, I want to move forward with using data in a better way and I can build your prototype. Look at this, look at the results, right? There's an example right here in the front, and of someone who's had this experience. But the teams that actually own that part of the business, you know, need to go along so that you can take advantage of the better decision power here, right?
Yeah. There's a lot of fear, clearly, and I mean, you see when people like Elon Musk make some, you know, dire predictions, like the machines are going to take over. There is a lot of fear then that inspires living, and in general, it's true for automation, not just you know, machine learning or anything. Automation always, you know, people have been afraid of, you know, every time there's a step function in what happens in the workplace, there's fear. And so there's resistance to change in any business, including the mortgage lending business.
And the final point's an important one too, okay? Do you replace people with automation or do you assist them? And, you know, at least our goal in working with our clients has been always to take the assisting approach. You know, it has a lot of benefits. One is you need to trust that the new thing works and it needs some human eyes on it, okay? Especially if it's in a core area of your business. And also because, you know, what you can do is you can take the mundane part away and let the machine deal with it. So for example, if you have a loan that's easy to approve or easy to deny, right? Let the machine make the decision, and when you have borderline cases, you can have that filtered set go to the human underwriters or whoever it is in your company for whatever the business process is. So I think there's a lot of room here to do it in a way which doesn't completely disrupt the business. All right, so I'm going to hand it over to Asim now.
So, Manish has given you the kind of the 101, and we got a great overview from Guha. But I'm going to get into deep this afternoon and in a particular case study. But I'm also going to go through 5 or 6 major areas in the mortgage business where there's a lot of data. It's fairly closed system data, so that you're not at the risk of getting tripped up by weird correlations that just don't make sense. The way to, in my opinion, having done this now for a long time, is that, yeah, you can have these weird correlations without causation, but you don't give it sort of, this data, what economists call network externalities, right? Because there can be all kinds of relationships that people come up with. There's a famous beer and divers case. There is we'll come to that one. Is that the next one? It's yeah. No, so go back. No, not yet. So, actually, go back to the slide. Anyway, this might, yeah. So, what machine learning is about, once we stop thinking of machines as robots, right? The kinds that were playing music and all, that is certainly a kind of machine with an intelligence or a skill. We want to impart certain skills to our machines, which otherwise look like just our regular computers. But it's through this process of supervised training, where there's a control process, what we describe, which can be a fairly dark art, just like developing any other system. So I did a lot of research on, how did this all start? And as always, Hollywood is involved in inspiring people to think. But there was go back to the quote. So this is the first line of one of the most famous articles or papers ever written in the field of machines being able to think. It's almost a philosophical question. So I have a bunch of wines. I'm going to ask these kinds of questions, and whoever answers the question will get domain serene. And it can't be any of you Tabankians who've seen this presentation. Who said this and when? So, anybody? It's a domain serene Pinot Noir from Willamette Valley, Oregon. It's a lovely wine. Had it many times. Turing. Who said that? Okay, what year? A decade.
That was before World War II.
No. Actually, this one was after.
Yeah,
So, 1950. Okay. So, you do get this. Just roll the video. So, we even have him saying this.
Could machines ever think as human beings do?
Most people say no.
Yeah, not most people.
Well, the problem is you're asking a stupid question. Of course, machines can't think as people do. A machine is different from a person. Hence, they think differently. The interesting question is, just because something thinks differently from you, does that mean it's not thinking? No, we allow for humans to have such divergences from one another. You like strawberries, I hate ice skating, you cry at sad films, I am allergic to pollen. What is the point of different tastes, different preferences, if not to say that our brains work differently, that we think differently? And if we can say that about one another, then...
So, obviously everybody knows this movie, many Academy Awards. Anybody want to just say the name?
Imitation Game.
Imitation Game. And so when he proposed this question, he actually changed the question in the second paragraph and said, can a machine play the imitation game? And that's where that movie's title came from. Anybody name the actor? All right. Who's the actress in this movie? Who's not featured here? There's no point for this question. Just want to make sure you're with me. So, all right. So now to more nuts and bolts. Next slide, please. Okay. So we see machine learning being applied in many forms of lending. We're starting to see it. There's some questions here. And I want to hear from you guys as well. Who's got active projects? But we are definitely seeing large investments being made, starting with the largest players. And one way you can tell is how many ads there are on their websites for employment for data scientists. And you see the large bulge bracket banks are hiring a lot of people. It's very, very much the case in, let's say, the hedge fund industry. They've got large amounts of data. Just this morning, yesterday on CNBC, they had the CEO of Man Group. And the amount of trading that happens on all kinds of asset classes in an automated fashion is growing rapidly. Where machines, with their innate abilities to handle large amounts of data. There's a lot of trading that goes on. We always fear that, it can cause a lot of volatility in the market. We actually have somebody here in the hedge fund business. Ron's here, right? So any thoughts, Ron, on a lot of ML being used in hedge funds across? These are one of the largest guys in the business, and they were like, they had the ratio of data scientists to traders, it's another benchmark, was enormously high.
Yeah, we see certain funds, particularly in the high frequency trading space, that are correlating data sets that would have been impossible to do so maybe 10 years ago. I mean, they're doing everything from counting boxcars in the Ukraine and then correlating that to how much of a certain ore is moving into the commodities markets and how that's going to affect futures. We see trading in not just equities and equity options, but in many other different types of products as well, where people are essentially using these massive data sets. And increasingly, the people that a lot of these hedge funds are hiring to do a lot of this modeling are not necessarily people from traditional finance backgrounds. And increasingly, we're seeing people with data science backgrounds and also backgrounds that kind of are cross-disciplinary.
Thanks, Ron. So, credit card business has always used. How many times has it happened to you? You're out there and your transaction gets denied fraud, and it's not. That's one of those where it's called a hot dog or not hot dog. But they've been big users of data and automated decisioning, predictive modeling for years and years. In fact, the team I had hired was predominantly people from American Express. They've always been leaders in this business and continue to be. We've listed some, we're going to do a lending club example. The new thing is people have started putting out their data for you to use and build a model on. They've just anonymized the data. Lending club, for every loan that it has done in the last 5 years, It's put the data out there, and they let you build models on it for the purpose of investing, for the purpose of analysis, or whatever you want to do with it. So there's a lot of practice data out there. So if you ever want to understand, there are tons of competitions on a site called Kaggle that people put vast amounts of data, and you can validate certain results you may have had with similar data. You can use their data and actually correlate it. So anyway, so these are 5 areas typically in any mortgage lending business. Obviously there's a whole ecosystem around it with insurance companies, title companies, and all of that. But I just take a standard mortgage lender example: marketing, origination, capital markets, servicing, compliance, some of the major functions. So models have been built in all aspects of these, the very same. They've been built for years and years with the tools getting better and better. So let's say when I was building some of these tools, this, it would have been logistic regression using SAS, SPSS, things like that. But today, I've sat with the data science team at Tavant the last few days and saw them use these new algorithms, and the speed with which they're able to produce results is stunning. So anyway, so I would like to hear your feedback, and is just to raise of hands, any active data science projects in the mortgage lending business, at least in this room? Because we know of many. There's huge investments going on with a lot of Tavant's customers, so a lot of prospects. But just curious, and because I would like to talk to you about, which particular areas you see. So just actually, just tell me, which of these areas do you see the biggest return on your potential investment if you were to do a data science project, where you see you have a lot of data? Is it, I want to see a show of hands on marketing, people have huge marketing spends? No? Is it mostly the origination part? Is that it? Looks like it. I see a lot of heads shaking. My background being capital markets, we used to find a lot of optimization in sort of these best execution type models, but that also had some predictive ability, especially if you are in control of your own destiny in terms of credit risk, which not everybody's in that business because we sell to Fannie and Freddie. Let's go to the next slide. Okay, so first one, origination. Especially, let's say, within the whole funnel side. So the whole origination process, we have loans that start off as leads, turn into completed apps, turn into approved apps, and ultimately get funded. So each stage there are barriers. There's a conversion process, and it moves along. But at each stage there's leakage. But from stage to stage, there's a labor cost being expended. So one of our most areas that you saw a huge lift. So for instance, pull-through rates, app-to-fund ratios, 8 to 22%. I've seen as low as 4 and 5% in certain businesses. 1 or 2% improvement in some of these numbers can mean a 20% increase in volume. Can you imagine a 20% increase in volume? If you were just good about how many leads you were able to get to apply. So there are models that can be built with data that's in the system already. This is data that you already have. Although you can turn on what Manish describes as UI telemetry data that is there in your UI or your, what do we call them, user experience, your portals, your consumer direct, your LO portals, your broker portals. There's all kinds of data in there that you can capture and be predictive about which loan is likely to close. So it's called the likely to close model. And depending on the range of probabilities that it tells you, you can assign it to different workflows and say, hey, you know, this one, and this one I'm going to send an LO to assist. This one is likely to close as a self-service. It's more likely. So your costs are low on that side. So you can route your workflow based on some of these models with data that you already have. So loan application data and historical borrowers. And I think there's a demo of this at some point on the conference of how this would work. So actually I'm also curious to see it. So, but this kind of stuff is now being embedded in the next generation of user experience software. So all your portals, you know, mortgage industry has lots of portals because it has so many external parties it has to deal with, including the customer. Am I on track?
Yeah, we have plenty of time.
Good, all right. So again, so we heard of robo-advising in the wealth management and stock brokerage business. It's actually very similar here. You know, you get a customer and you know, it's a big thing. It's one of their biggest transactions, buying a home, even refinancing a home. This is not something we do every day. It happens, the buy side happens once in potentially a decade. And the refinancing, again, it's so dependent on so many different parameters that, you know, and then we tend to have so many products with so many variables and so many permutations and combinations. And, you know, even well-qualified loan officers have a really hard time finding the best product. So there are, again, models that can be built using the full historical origination data stack, which tells you, you know, what kind of loans do people tend to pick, and statistics on past borrower choices. So I guess some of this is it's from one of the demos, I think. We'll skip that because you can actually see the real demo. But the idea is to recommend the best possible product, which is your, you know, you don't necessarily, a robo-advisor doesn't necessarily mean some kind of Siri-like device, but it could just be better description of choices and different permutations and combinations, distilled down to one or two or three.
Yeah, and specifically here, this example is showing that when someone has a very low down payment, you can show options like an 80-10-10 scenario, right, with a second mortgage, not just options with mortgage insurance, right? And what makes sense for the borrower may depend on like how quickly they can pay down that second loan. That might be a better deal for them than the case of going with MI. So that's the kind of stuff that would be nice to work in to your systems. From what we've seen these days, the direct-to-consumer portals tend not to expose this wide variety of choices to the audience, right? You have to talk to a loan officer to see these other combinations, like an 80-10-10 loan, and even then, you know, how is that choice being guided, right? We can do better.
This one's a really good one. Any?
I heard the term.
I heard the Terminator back there.
Terminator. No.
2001.
2001 Space Odyssey. No.
Earlier.
Yeah. So actually, let me clarify. It's not the term AI, but when was the concept of AI are artificial intelligence, which involve learning.
Is Frankenstein correct?
Close, very close. Yes, very close. So,
The Invisible
Blade
Boy.
Runner. Blade Runner, it's much later. Okay, so let's roll the video. My job. Movie buffs.
Good machine.
So Nuit Saint-Georges. Okay. Any guesses?
Metropolis.
Metropolis.
The first time.
Well, did you say that?
Yeah, but
Oh.
I cheated, I have it at home.
That's awesome. Okay. You have the role. Can you tell us a little bit? What was the? Have you seen the movie?
Many years ago.
Okay.
I think it was in the 1930s, I think.
Yeah, actually 1927.
Oh, boy.
1927. German. No dialogue. Only music. This was the remastered version from the 80s. And the storyline is, this robot is created, and it is turned into the twin of Maria, and she learns. This robot learns to become totally human. So therein is the artificial intelligence. So the term AI was not used because it was a silent movie. So, but that's very, nobody gets that. Give them two. Huh? All right. Thanks. All right. So this is the meat of it. This is where there's the most data. It's actually in fairly good shape because so much of it is subject to compliance and regulatory measures. This data happens to be in really good shape. It's very predictive. And we've used a subset of this data for our afternoon session. We have lots of issues here. We often misprice credit risk. Lots of reasons for it. We turn away good borrowers. They just slip through. It leads to higher origination costs because we do extra work on loans that don't close. It's wasted labor. It's that leakage in that funnel. From every step, as you go forward, you are cumulatively adding on labor costs. So if you look at, if your active fund ratio was 10%, it means, there's so much labor being expended on the 90% that don't fund. You've spent almost the same amount on loans that don't fund as the amount we do on those that do. And so our average cost in this industry ends up being, $7,000, $8,000 per loan. Ridiculous, right? You can make a car for that amount. There's just blatant underutilization of just so much data because it's there, but we're constrained by lots of factors. The fact that we don't care because that's the mandated process. There was a MIT Sloan study, which we've provided the link here for, that where they used machine learning and found a huge amount of predictiveness. So, delinquent customers' losses, we could have cut down 25% if they just used the models that MIT built. And again, this is similar to models, again, being built today. Actually, Fannie and Freddie are starting to figure out how, because they have vast amounts of data. In fact, we have built, Freddie, I think, released a lot of data, anonymized, no privacy information, and you have 15 years worth, and you can actually train a model based on that, just to see it go through many cycles of financial crises and hurricanes and whatnot. So, and then we have Fair Isaac in this business. Essentially what they've done is they've taken one piece of the data in this business, which is your credit bureau data, and they've built the score that is predictive. It's not predictive of any specific event, but it's predictive of your general credit behavior. And we've learned to kind of lump all that data into one place, but not use all the components. When you disaggregate the whole credit file, there's just a lot of data. It's one of the best sources of data we have found. It's better actually to just take out FICO. If you are responsible for your own credit, which you are, if you are a bank, a REIT, an insurance company of any kind, or just somebody who buys loans on a correspondent basis, you are taking some credit risk. And it makes sense to get the best possible credit decision with the data you already have. Thanks. So this is, again, another hot topic these days. There's a lot of alternative data out there, of sources of data that have predictive value. In fact, there are companies that have built a model exclusively taking that non-traditional data. For instance, to cater to thin file borrowers, first-time borrowers. Well, they still have credit in other forms that are not stored in your traditional 3 credit bureau systems. There are other predictive elements. Education level is one of my favorite. Employment history. Retail purchases is a controversial one. And how you get it. So all of these do have some issues, but for instance, CFPB announced that they have no issue, essentially no action, to this company called Upstart Network, which uses machine learning and uses a whole bunch of alternative data to provide credit to non-traditional borrowers.
And actually, that no action letter also called out, notice the use of machine learning.
Yeah.
If you've read the text of it. So I think it's a good precedent-setting thing. It doesn't mean that anything you do will also be blessed, but it means that there's at least, the regulators are learning about this and are being flexible, right?
So, as I said, especially those 5 classes of lenders, portfolio lenders, correspondent lenders, those who portfolio HELOCs, those who are in the mortgage insurance business, those who securitize certain loans that are non-agency loans. They are taking significant credit risk, and it's in their best interest to have the highest risk-adjusted returns on their portfolios over the long term. And even, in my opinion, those that sell Fannie Freddie product or FHA, VA product, but retain the servicing. There's so much of value in servicing, including the portfolio retention value, which we'll get to next, which is one of the most successful applications of predictive modeling as well. Again, the data is data we already have. It's very predictive. This has been done. A lot of large lenders that have large servicing or balance sheets use all of it.
Hey, see, this is a good place to put in your point about how the traditional way of ingesting credit data takes it, distills it down to a number, then throws away the raw variables. And
Yeah, so this has always been, we ran a model in machine learning, which was, you know, this was before the financial crisis. We did one thing, we loaded 24 months of full credit file. 24 months of the full credit bureau was loaded onto a bunch of servers. And we looked at the time series of credit data and saw, you know, said, hey, tell us what is predictive? Because the hypothesis was you have two borrowers with the exact same FICO score, we would treat them exactly the same. So let's say we have two borrowers, A and B, 700 FICO score. However, 6 months ago, one was at 650, the other was at 750. Which one is a better creditor? Clearly, the one that was 650 going up, not the 750 going down. Yet, all our systems, we love matrices, we love add 25 for this, add 50 for this. It's always round numbers. So why is it not 32? Because risk is continuous. Or risk is offset by other factors, but humans can't quantify the exact effect. And that's what some of these models do, is they distill it down to a probability, taking into account all predictive variables. So we throw away so much data that is available. Now this particular case, 24 months of credit bureau data is actually not available at the time of origination, because the credit bureaus are not structured to give you that snapshot in time on demand. They can do it as a batch project. Some of them are actually working on it, which is going to be very interesting. I could get your FICO today and FICO 6 months ago, potentially. That could be very interesting. That was very predictive in terms of default. Any questions? All right. Okay. So the other thing we've done, so if you look at all the data we have in this business, right, it's just a lot of data, right? And let's say it's all individual attributes. Credit is a big one. You have income, assets, property data, you know, then there's all, you know, title, escrow, there's tax, there's just, say these are the big ones. What we've done is we've seeded ground in terms of predictive ability to distill this down to FICO.
What we've done as in what we're doing today,
Yes,
as opposed to what we could do.
Oh, okay, yeah. What we find is that individual components of credit are much more predictive. And then we take the FICO score, then we add debt to income ratios, we add, you know, LTV, and we've built some 2, maybe 3-dimensional matrices-based systems out of this. Whereas ideally, you would take all the data and make it into the equivalent of one FICO score.
Before consolidating it, right? So
Yeah.
give a learning model all of the inputs so it can find more patterns and
Yeah. So we've biased our systems to give us not the best answer. And in fact, the over-reliance on some of these scores, FICOs, and there are other versions of these scores, was listed as one of the main causes, you know, but 25%, let's say, of the financial crisis. So, because everybody uses it the same way, and everybody doesn't use the time series aspect of it, and so, guess what? It causes a lot of volatility. It's like machines trading, and when they all start selling, the stock market can crash. And in this case, the whole world crashed. So, next one. Okay. All right, so capital markets. Again, one of my favorite areas. You can build a lot of execution optimization based on these data sources. Here, this is where you add macroeconomic data, and then it really excels because you can, and so Stanford, in this case, has done a study where they took 15 years, or maybe 20 years almost, of Freddie Mac data, overlaid data from macroeconomic sources, from CoreLogic, and built a humongous machine learning model and found it to be very predictive. And they came to some of the same conclusions that, they didn't use pre-aggregated scores. They used the individual components of the credit file. They didn't distill it down to FICO. They wanted to see, how in the individual trade lines, the number of trade lines, and the usage percentage of trade lines, how they're individually predicted. But again, if you ask a capital markets guy, they'll say, you don't need to worry about this whole pipeline, this, that. If I can just get you 5 basis points extra, you don't need to worry about anything. 5 basis points more on $100 billion, we're very happy. So this is where, just slight variations in execution improvement, just like the pull-through rates, that's a huge levered number. You improve 1 or 2% here and there, your volume would go up by 20%. Portfolio retention, I'm sure this is, if you have a servicing portfolio, you have a portfolio retention strategy. If this borrower is going to refi out or buy a new house, you want to be the ones to provide them that next mortgage. Why should it be somebody else? There was a cool meme here, but we took it out. But anyway, so the thing is, and a really good model should ideally tell you before the borrower knows they're going to refi. It could be up to 3 months in advance. Most of us, we have a portfolio retention strategy. I believe Tavant has done some work with some lenders on, more aggressive strategies where, they're reaching out much before. But typically we get a VOM at the servicing department, and then they scramble and start sending them counter offers or better offers or something. But this is not just increasing the value of your MSRs, it's also increasing the value of your origination revenues. So you get it both ways. Sorry, did I miss something?
No, I was just going to say that if you're a little bit better, you might be looking at credit inquiry triggers from a credit bureau to give you a heads up. But at that point, the borrower's already applied somewhere else, right? How likely are you to track them away? So you need a bigger prediction horizon, like 3 months, 6 months.
Okay.
And the data.
So there's some interesting news sources here. Like moving predictions, smart. So if the borrower is going to move, you could know the fact that there's some activity of a certain kind and reach out to these borrowers before they go elsewhere.
That company, as an example, claims to give you a 6-month heads up on who's likely to move in a neighborhood, as an example. So that you have some time to go reach out to them. Now that's only for the people who are moving, that's not all the situations, but at least one thing that you can do that's better.
Servicing portal activity, that's a very interesting one. Here's a borrower who never really visits your servicing portal, but suddenly starts visiting there and calculating the payoff amount multiple times and often. It's a real big trigger.
We also work with the New York Times, and someone was telling us about how they detect churn on subscribers. We did not work on this model for them, but they were telling us about what were the big indicators of subscriber churn at the Times. And there's two things. One of them was when people stopped reading the editorial content, which is more unique. The second one was this, is when people were on the My Account page, looking at their subscription when it ends, or what the price would be for renewal at the Times. Because people don't normally go there.
Loss mitigation, again, I don't want to get into a lot of detail, but again, this can be one where you can get a lot of regulatory scrutiny. It's in your best interest and the borrower's best interest where you minimize foreclosures and you look at alternative ways. And so being predictive about it and predicting the propensity to default, you can offer assistance or loss mitigation tools ahead of time before things get really bad and then there's no recovery. So, next. Okay, so what are you waiting for? There's been a lot of hurdles in our way. We are faced with regulation of all kinds. But at some point, it's not a question of will the machines destroy us. It's actually your machines against your competitors' machines. And who was fed more data, who was fed better data. As Guha said, you feed them data, you create a history, you create a moat around yourself because you have a better model, which means you will have lower losses, you may have lower putbacks, you may have better servicing value, you may lower your costs because you have a better pull-through rate on your active funds. It will drop your costs, it will also increase your volumes, which is a double benefit. So it's a question of the costs have come down significantly in terms of building models. I encourage you to visit this site called Kaggle. It conducts contests and competitions to try and figure out. They put their data out there and let people tell them what's predicted. There's lots of alternative sources of data that can give you a competitive advantage. Mortgage lending, we showed you all the processes, from end to end, from lead management, propensity to apply. We used to score every single lead, buy them from LendingTree or wherever you buy them. You score them, and you decide this goes here, this goes here, this goes here. Which but the large lenders, the larger they are, the ones that have really started aggregating data and starting to build models, or if they already don't have them, many of them have been investing in certain aspects of these models for years. But thanks to open source. 10 years ago, it used to be you needed a $1 million, $2 million license, or the SaaS license, and so on. Now, actually, all the tools are mostly free. Open source. So, understanding it?
Just the answer to the question.
So again, just any thoughts, ideas, which areas are more important to you, or any questions about what we've discussed or what he's discussed. This is we're obviously going to have a more hands-on demo, which will show you the process, what was described as a dark art. Sort of show you under the wraps how that works. And by using a lot of data, and in certain industries now it's the only way. It's not an option. So for instance, the whole lending club example that we've used, they just put out all their data and say, hey, you can invest in loans based on a model that you may have built or a system that you may have built. But questions? Yes, sir.
So when you make the statement that large lenders are using ML to gain competitive advantage,
Right.
a couple of times you noted that large lenders are using machine learning to gain competitive advantage.
Yes.
Have you seen that anywhere on the origination side? Simply because if you look at what's going on from an industry and GSC level, you could almost argue it's moving in the opposite direction. In other words, if you do qualified mortgages, if you now do day one certainty through Fannie,
Right.
you pretty much take risk off the table.
Right.
And that's taking the human element out of it, but it's also taking any sort of cleverness out of it because you're fitting it into a box. So I'm just curious, when you make that statement,
Yeah.
Outside of other types of loans, but within mortgages, you're actually seeing anybody use ML for mortgage origination.
So you're 100% right. Where we see most of this activity is in jumbo loans and non-conforming loans or non-prime loans, HELOCs, things like that, where it's possible to arbitrage out of the standard box of Fannie and Freddie. That actually takes away your ability, but you can have it in other areas where you can increase your pull-through rates, for instance. That, Fannie and Freddie has nothing to do with that. So you would invest there and not necessarily in assessing credit risk better than, let's say, Fannie and Freddie can, right? It's not your model. But if you are Redwood Trust or somebody like that wants to buy a bunch of mortgages, or you're a community bank that wants to portfolio some mortgages, you want to know which are the good ones that I should buy, which are the ones I should reject. So depends on your business model where you would make the investment, but the large guys do everything. So they have a lot of data, and so they collect all the data, and then they're starting to build models. And so theoretically, this is where there is credit arbitrage, is they may find a certain loan, it's better to hold on than to sell to Fannie and Freddie. Because, you got the balance sheet, you're JP Morgan, that's it. You would just hold it. Why sell it? If it's an ARM, you don't have interest rate risk. You have a little more control. So it varies by the business model. You could be investing in servicing. So even if you're selling off to Fannie and Freddie, but servicing retained, that's a great source of steady revenue. And it's a good part of the MSR calculation is if you have lower prepayment rates than the next guy, your MSR is going to be worth more. More questions?
So, given that such a big, the whole idea, think of figuring out applicants' future economic behavior is a big part of what you're trying to do. And the company that has the richest, most fine-grained data about your economic behavior today is Whole Foods.
Yeah. So
When do you think they're going to enter the market?
Yes. It would shake things up because, we talked about spending patterns, for instance, being triggers for many things, and who has the most data is Amazon / Whole Foods. Yeah.
They tried once in partnership with Wells Fargo.
Yeah.
And I think they got into some trouble because they were, because of some of the data usage.
Yeah.
So they put that on hold for a while.
Yeah.
And I'm pretty sure that they will do it.
They never give up.
Yeah, they'll come back at it. I'm convinced that, they will use their physical presence and their ability to distribute and their their data capabilities will, they have clearly an advantage. I mean, this is just a fact. It's a matter of time. And they're very good at using data. So.
Time for one more question.
One more.
So it seems like most of the things we're talking about with machine learning right now and today is around cap markets, around risk modeling, right? And on the origination side, it seems like trying to figure out where can we apply this more towards process automation and making the loan flow quicker and cheaper, right?
Yeah.
And it seems like didn't really get too many ideas around that right now. It seems like most of the things are on large amounts of data to.
Actually, go back to the minute. So go back to origination. So there's these adaptive UI portals. So your user experience needs to be adaptive based on triggers that you may be capturing this. Go to the next one. Next one. Where is the telemetry data? So, Manish, which was
Probably earlier.
Earlier. One more. Oh,
Keep going.
Go
back.
go back. Yes. Here.
There we go.
So in your UI, you start capturing. So your system, first of all, has to be built that way. And this is the one I'm saying. There's actually a demo of something like that, where you start seeing this adaptive workflow, where if a borrower is spending too much time on a certain step of your process, that's a trigger. That's data that should be captured. If a certain time between two steps in your process is longer than the average of 3 days, that's a trigger. It should be captured. So this data is built in there. You want to answer a little bit of this?
Yeah, because we're doing some of the stuff right now. As Asim started on, the importance of machine learning in the origination business is to be able to provide as much self-service to the borrower and basically take a lot of processing away from actual processing into the origination phase, in the app intake phase itself, where your loan officers are smarter in pre-processing the application based on the customer journey that has happened thus far. So the three important points there. One is, how do you create a persona for an individual coming to apply for a loan regardless of the channel, whether it's an online channel, whether it's a consumer direct channel, whether it's at a distributed retail branch. How do you do that to ensure that the customer goes through a loan in as minimal steps as possible? So that's one area of machine learning where you're learning from past consumer behavior to predict how does someone fit in a particular, or what, not fit rather, how do you offer an experience to a consumer that takes them in that journey in closing a loan in less than 15 days? That's one area of machine learning. The second is around best execution, which is product recommendation. So in today's world, you need a very experienced loan officer to be able to deal with something like California market, where average home prices are in the Bay Area probably $1.2 to $1.5 million. And with millennials coming in with less than 20% down payment, are you offering an MI-based loan product? Are you offering a piggyback and a simultaneous second? Are you offering something unique to them? So that requires a very smart loan officer to be able to construct the loan in their heads while they're having their conversation. In a 30-minute initial conversation, can the system predict recommendations and tell you this class of borrowers with these attributes and parameters often do well with these kind of products? So instead of capturing or getting to that information during underwriting, you can do that upfront in your loan application phase and take that customer through a journey that converts more of your apps into approved and funded loans. The third aspect is all around the fact that the system is learning based on the steps that each individual takes. So it's not just the borrower, it's the borrower, the loan officer, the data coming in from third-party sources that predicts the nature of that loan in terms of conversion within a 15-day cycle, within a 30-day cycle. So you can predict the workflow, the process steps that you need to take to be able to do a high-quality loan in the shortest amount of time and cost possible. So those are three areas of machine learning.
Perfect. Thanks, Abhinav. And with that, I thank Aseem and Manish for this great session. Thank you.